Hello. In this video, we're going to let f of x equal the square root of x minus 1 and g of x equal 2x plus 5. Then we're going to find the compositions f composed of g of x and g composed of f of x and their resulting domains. So if you look at f composed of g of x, what that really means is that it's f of g of x. So this really just means f of, and then replace g of x with what it is. In this case, it's 2x plus 5. So that means we go back to the function f of x and replace the x with 2x plus 5. So that's going to give me the square root of, instead of x, it's 2x plus 5, and then minus 1. And notice that plus 5 minus 1 is just 4, and that gives me the square root of 2x plus 4. So that means that f composed of g of x is the square root of 2x plus 4. There we go. Much better. Fantastic. So this is f composed of g of x. I'll come back to the domain in a second. Next, let's look at g composed of f of x. Well, that simply means g of the f of x function. So what this means is that we're actually looking at g of whatever f of x is, which in this case is the square root of x minus 1. Then you simply go back to the g function and replace all the x's with the square root of x minus 1. So this is going to become 2 square root of x minus 1 plus 5. Notice that literally this x simply becomes whatever this parentheses is. Okay, so 2 square root of x minus 1 plus 5, there's nothing you can do here, so that means that this is actually g composed of f of x. Fantastic. Next, I want to look at the domains. With the composition domains, the first thing you always look for is the domain of the second function that's listed. For a here, it's the g function, which is 2x plus 5. And the domain for a polynomial is always negative infinity to infinity, all real numbers. Then you look at the answer, the square root of 2x plus 4. And notice that it is a radical, which means that whatever's underneath the radical, the 2x plus 4, must be greater than or equal to 0. It's an even radical, sorry. So we're going to subtract 4 and divide by 2. So x is going to be greater than or equal to negative 2. Now, where it's true, where the domain is all real numbers and the domain is where x is greater than or equal to negative 2, or if you wish to see it in interval notation, negative 2 to infinity, that means that all real numbers intersected with negative 2 to infinity is just negative 2 to infinity. So the domain is going to be negative 2 to infinity. That's for f composed of g of x. Next, we're going to look at the domain for g composed of f of x. And again, we're going to look at the second function that's listed, the f of x, and find its domain. Again, we have a radical, and the radical in this case is x minus 1. Square root of x minus 1, sorry. Add 1 to both sides, which means x must be greater than or equal to 1, and that's the domain. Next, let's look at the answer. Well, the answer has another radical, an even radical, so the radicand x minus 1 must be greater than or equal to 0. Add 1 to both sides, so x is greater than or equal to 1. Notice that these are the same thing. So the intersection between them is itself. So in interval notation, this is going to be 1 to infinity. Alrighty. Well, have fun. We'll see you in the next video.